I recorded my third hour, but I didn't do a great job, so we're going to use you guys. And I just recorded. Okay. So, third hour. Okay, here we go. So, in order to create a number that is in scientific notation, okay, so you have to know where we are. We're starting with a number that is not in scientific notation. And we're going to try to put it into scientific notation. The rules are that you can only have one number in front of the decimal, and then you can have a few other numbers if necessary, and it'll be times 10 to some power. And the only numbers that can go here are the numbers 1 through 9, nothing beyond that. Okay? And then the steps are listed there. Step 1, move the decimal so that there is only one digit on the left-hand side of the decimal. Again, 1 to 9. Then pay attention to the number of spaces that you're moving, not the number of zeros. Not the number of zeros. That happens often. That's why I'm stressing it. Only the number of spaces and which direction you are moving. If you move from the left, the exponent will be a positive 1. If you move to the right, it's going to be a negative 1. Then you take away any unnecessary zeros. Okay, I have been doing this for 12 years, 10 of which have been in algebra. To this day, I can't remember what I'm doing, but I can do common sense really, really well. Hi.
That's true. I have a Chromebook here for Valerie. Oh, she's Valerie. I found Valerie. Yeah, you're my favorite aunt.
Thank you. It's on my recording, so you just got there. Bye-bye.
Oh. Why did the chicken cross the road?
Go away. Okay.
Tell you next week.
I have to deal with him regularly. Okay. Okay, so here's the deal. So here is this random number, okay, and I need to turn it into scientific notation. Again, the rule was I have to have one whole number between 1 and 9. So if you look at this number, right here is where I'd like my decimal to go. Okay, so I would actually write the number 5.01. So right now I would have 5.01 as my scientific notation number so far. Now I have to figure out what power of 10 I'm needing. Well, I started with the decimal here. Always start with the decimal that's actually in the problem. And I'm going to move 1, 2, 3, 4 spaces. So I'm going to have an exponent of 4. But since I moved to the right, that exponent is going to be negative. So my final answer would be 5.01 times 10 to the negative 4 power. Okay, now I'm going to tell you my common sense because I can't remember left or right. Never have been able to. Okay? Common sense tells me we have been dealing with negative exponents last week for a while now, right? And so if I said, and please get this right, I'll be so embarrassed. If I had this, and I asked you to simplify it, in other words, get rid of the negative exponent, what would this turn into? Where does this need to go to become positive? To the bottom. So it'd be 1 over 4. Isn't that a number smaller than 1? It's a fraction, right? So wasn't this number smaller than 1? That means I know I have a negative exponent. Because my original number was smaller than 1, I'm going to have a negative exponent in my answer. That's common sense to me. And so if you forget the left or right, try to use some common sense. And as we do this more, it'll make more sense. Yeah. Okay. So now let's go down to the next example, B. Again, we're trying to put it into standard scientific notation. So where would you really want this decimal to go? Between what numbers?
1 and 6.
Between the 1 and the 6, so that I have truly one number in the front of the decimal. So here's what it would look like. Now I have to determine how many spaces I moved. Well, it was here, and I'm now moving to the left. So that means I need to make it a positive exponent, and I move 2 spaces. So they're telling me it's going to be a positive 2. Common sense says, was your original problem bigger than a 1?
Yeah.
Then I'm going to have a positive exponent. You don't have to worry about, am I moving to the left, am I moving to the right? You're using a fact. It was a number that was bigger than 1. It's got to be a positive exponent. Okay? See if you can do the triads on the right-hand side. And this is where we'll talk about removing excess unnecessary zeros, okay? So see if you can write that into scientific notation. I got that part. Nate? Okay, hold on. 2.0. I have good hearing. 2.01. Okay. Now, why did you stop at the 1? You did it right, but why? Because they were unnecessary zeros. When you got to the 1, these zeros no longer mattered down here. We'll make up for all those zeros over here using our exponent, okay? So times 10, and now the original decimal would have been at the end of this number like a period in a sentence. And I had to move 3 spaces, 6 spaces, 7, 8 spaces, so I have an exponent of 8. Make sense? Okay, all right. Let's look at the next one. What do you know just from looking at this number? It's going to have a negative exponent immediately, so you know that much. Okay? So who could tell me where I would want the decimal to go in? Okay, look, Landon. Yeah, 7.25, perfect. I'd love my decimal to go there because I'd have a 7 by itself and then a 2.5, and it's going to be times 10. And I know it's negative because it's a tiny, tiny number, and I moved 6 spaces. Outstanding job. Outstanding job. We good? This is, yeah, this is just, well, this is the beginning of your homework. Kind of, yeah. No. Because I love you, I torture you with hard math. Okay, let's keep going. I feel that you're getting the hang of this part. Let's see if you can do the try it. On the second part of these try it's where it says example 2, we're taking something that's already been written for us in scientific notation and reversing it into what they call standard notation, which is how we write normal numbers. Are you going to give me an answer? Let people work it first, but I'll call on you, okay? So look at try it A. Look at your exponent. Now try to create a number that works in our standard notation. Okay. An 8. What you got? Perfect, because here's where the decimal was, and this is telling me I need a positive. This is positive, so it's going to be a really big number, and I need 6 spaces past my decimal. So 3 spaces, 6 spaces. Good job. Okay? You okay with that? Yes, ma'am. Oh, you want to do the next one? Yes, you're speedy. Okay. Oh, let me think a minute. Okay, I'm processing. And what have you got, Miss Elizabeth?
I got 9 billionths place.
Okay, you blew me away on that one.
How'd you know that?
I was tens, hundreds, thousands, millions, billions, and then you move on to billions.
Good job. Okay.
Uh-huh.
All right. Okay. It seemed real easy to you, didn't it? No, it's not easy to me because I'm clueless sometimes. All right. Step 1, we have to have our pretty zero. That's required in scientific notation. I know. Now, so this is my real numbers. Okay. So it's a negative. That means I know my number is going to be very, 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 very small with lots of zeros to the left of it. So if my decimal is here and I have to move 5 spaces, so I'm going to have 4 zeros, then the 903. So I wound up having a total of 5 spaces by the time I got all done. Okay? It's kind of crazy ugly, isn't it?
Yeah, moving around.
Yeah.
You must take it.
Yes.
You always put 0.
Yeah.
Like positive, you can spread on the left side.
You can't. If you don't have a whole number here, you have to put a pretty zero. Well, no, it moves because we had, I mean, it depends on what the problem looks like. It's not going to be always anything, I don't think. I'm not sure I understand your wording, but okay. All right, let's do this. Flip it over. Let's get started, please. Come on. I want you to have time for your homework. All right, now we're going to multiply when things are written in scientific notation. The idea here is your normal numbers times your normal numbers. And then if you can go back to where we've been talking about bases that are matching. Remember we had variables that had matching bases, and what did we do to the exponents? If we multiplied, we add them together. When we divide, we subtracted them. We're going to follow that pattern. So if we look here at this example, okay, I have 4.1, I'm going to call it a normal number, and an 8.2. We will multiply those two values together, and you can see they're showing you here in the notes that that's what they're going to do. You get this answer, 33.62. So I took care of my normal numbers, didn't I? Now I have to deal with the times 10 part of the problem. I'm glad you recognize it. That's exciting then. Okay? So I have bases that are matching. The 10s are the base. They're matching. They have exponents. So I'm going to add their exponents together. So what is a -5 plus a -2? A -7. All right. Right here is a good answer, but it is not scientific notation. You've done great math, but you're not finished. Scientific notation is required. So I'm going to have to move my decimal. And here is where students fall off the bus on me. Okay? If you have to move your decimal to create scientific notation, you're going to have to change that exponent as well. Okay? Because you don't want to change the value of the number. You just need to change the way the number looks. And I need you to kind of follow me here for just a minute, because I'm going to make this really easy with common sense if you'll follow me. Ready? Okay. I need you in your calculator I'll make that a 3. And that's a 2. Okay? I want you, if you would please, calculate each of these numbers. What is 3.45 times 10 to the third? 3,450. Okay? And what is 34.5 times 10 squared? Okay. Please notice, their overall value is exactly the same, right? Okay, but I scooted the decimal, didn't I? One has the decimal in a different place than the other. And because I scooted the decimal, I also changed the exponent. And here's the deal. And this is where common sense is really helpful here. When you're having to adjust a problem, for example, this bottom number is not in scientific notation, is it? So if I had to put it into scientific notation, I'm going to have to scoot the decimal over 1. You'll have to adjust your exponent to show that. Where students get confused is to what will the new exponent actually be. If you move 1 space, you'll change your exponent by 1 value. If you move 4 spaces to make that happen, you'll change your exponent by 4 values. Now pay attention. because this is particularly when it's negative numbers, it becomes very awkward. I want you to pretend, if you will please, that we're talking about pounds, okay, or weight, something that you can visualize a little bit, okay? If I have something that weighs about 3 pounds, and I need about 3 of them to equal this number, okay, just play along with the idea. If I suddenly get things that are like 34 pounds, and I want it to weigh the same, am I going to need more of these heavy things or less of them? Common sense says less of them, correct? Notice my exponent is less than the other one. So common sense can be helpful here. Now let's go back to our negative where we were when we left off, okay? This was not in scientific notation. We need to put it into scientific notation. So, oops, I'm sorry. So scientific notation would make it turn into 3.362. Now, what power of 10 will I now need? Well, if you use the common sense part of it, they did weigh 33 pounds. I know it did weigh 33 pounds. We're making that up. And I needed 7 of it. Forget that it's negative, okay? I now have them and they weigh only 3 pounds. Does it make sense that I need more of them? So that means I need a bigger exponent than a negative 7. What is an exponent that is 1 bigger than a negative 7? Negative 6. And that is your final answer. 3.362 times 10 to the negative 6. They're showing you mathematically here how they got that answer, okay? They scooted it 1 space, and because they scooted it to the left, it was a positive exponent. A negative exponent and a positive exponent, when I added them together, got to the negative 6. It's just, for me personally, it's easier just to use common sense if I need more of them or less of them. We're going to do some. It's going to get better, I promise, okay? So, take your calculator, and let's do this, try it. And this is an Oprah problem, isn't it? Power to a power. So, you get a 1. And now we have to multiply, correct? So we have 7.8 squared times 10 to the negative 8. Come up with a real answer for 7.8 squared. Tell me what you get. 60.84. Good job. Okay. Is this in scientific notation? No. What do I need to write to make it scientific notation? Okay, so what would I have? Which way? Okay, so 6.084 times 10. This is where the negative exponents, be careful. Be careful. Negative exponents are opposite of what you think, okay? You had a 60 and you needed 8 of them. You turned it into something much smaller, to a 6, so you're going to need more of them, right? What is one exponent bigger than a negative 8? Negative 7. Good job. Does that kind of make a little bit of sense? Okay, try the next one. Thanks.
Cameron Terry.
Okay, see if you can do this one. Normal times normal, base 10 times base 10. You're such a celebrity in my classroom.
To get to the other side was the answer.
Oh, thanks.
Yeah.
Okay, bye. Okay.
Bye, Cameron.
6.5 times 8.7 is what? Hot louder. I'm old. 56.55?
Yes.
Okay. And times 10 to the what now? Negative 3. Good job. We added our exponents together on the basis that match. Is it scientific notation? No. So what does it need to be? 5.655 times 10 to the negative 2. Now, what would it be if I wrote it in standard notation? Now. Oh, babe, watch out. This is a negative exponent. I have to go that way. 1, 2. So I have to have 0.05655. That's going to be your standard form, okay? That's if you need to put it in standard form. This was already in standard form. Okay, this was already in standard form, and so I'm just using common sense, saying I have a negative exponent, I need to make it a smaller. Okay? But this one's in scientific. I didn't have to change it to scientific to put it into standard. Well, you were busy talking, so you missed it. Whatever. All right, let's do division. Division is, you know how to do that, right? Normal numbers divided by the normal numbers. So it follows the same pattern. So you're going to break your problem into 2 sections. Your normal numbers, just divide them in the calculator and come up with your number. But what do we do to exponents on bases that match? When we divide, we subtract. So you have a -7 minus the -6. So you got a -1. And that's your answer. Is it in scientific notation?
Yes.
Yes. If it says yes, don't move it. Yes, ma'am.
There's 2 negatives, minus.
It does. It did. It did. Okay? Now, what would this look like if you put it in standard notation? Pretty zero, 0.1525, okay? We are not doing the bottom part here, so you can just not worry about that. But do start your assignment, and I need you to know how to write 1.5 billion. Because the first problem you start with on your homework, you have to know what 1.5 billion looks like. Billion. Billion, like in my bank account. Billion.
You thought.
You're at 2-1.